Good afternoon to all of you, and welcome to the second webinar for October 2013 for the Smart Grid Educational Series. I'm your moderator, Irfan Ibrahim, and I welcome you to this webinar. We're going to have a 90-minute presentation by Stephen Dawson, and we will have a question and answer at the end of it. The presentation and the webcast recording is going to be made available by tomorrow to all the people who have registered. Before we get into the presentation and also the preamble to the presentation, I wanted to alert you to an event that is happening in the White House on December 12, 2013. It's a Smart America Challenge workshop, and they are seeking applications. If you have test beds that you would like to use in this demonstration, it would be good for you to apply. And then on the 12th of December, there's going to be a workshop in which you will see how these various parts fit together. And I will provide you this PDF document so you have access to all the information, but I wanted to give you a heads up. Jeff Mulligan, who is a Residential Innovation Fellow and is currently residing with NIST, has shared this information with me, and it looks like a very intellectually stimulating and rewarding experience for industry stakeholders. Now let me get into the presentation with Stephen Dawson. He asked me a few months ago about doing this presentation and has been hard at work on his project to share this information with you. As a preamble to this presentation, I would like to say that given the current trends in the energy sector, especially in North America, where we are increasingly moving away from centralized power that's being generated by nuclear and coal, and moving more into distributed energy resources using solar and wind with storage, the need for demand response is growing more and more. In the past, you would have some days that you would need to clip the peak in hot days or in cold days. Hot days primarily because of HVAC system and the load that air conditioning would have on the grid. And in the wintertime, it would be mostly water heaters, especially in the northeastern part of the United States. But now with more and more of the added capacity being renewable energy and those centralized power systems slowly going away, either they're reaching the end of life or we are moving into this distributed energy resource model, what happens is that because of the intermittent aspect of renewable energy, the supply of electricity is not uniform the way it would be if we were depending on coal, nuclear, and hydro. So as the renewable energy, and I'm talking about now non-hydro renewables, so we're talking about solar and wind, as these two sources of energy become a larger and larger percentage of the energy mix, the overall supply of electricity will also have not a horizontal profile, but it will vary as a function of time. And so in this environment where the reserve spin is becoming thinner and thinner or narrower and narrower, it is very, very important to enable demand response applications to be able to shape the load to match the supply of electricity. So this is no longer a 1% issue. This will be the case throughout the day, day after day, independent of the time of the year. And so in that environment, if we don't have automation on appliances at the customer premises, whether it be industrial, commercial, or residential, we are going to have a very difficult time enabling these demand response applications. We don't have the luxury of just making phone calls or doing emails and telling people to turn certain things on or off. Or even send a signal, like a price signal, and then just automatically assume that people are going to adjust to it. We need to bring automation into this area. And so many people are like-minded with me in this industry who have started various initiatives to look at how can we automate the process by which a signal comes and then it causes change. So whether it's the smart energy profile and its development in the customer premise, whether it is using protocols like BACnet and Modbus and LawnWorks and all of these various protocols in commercial and industrial and various others like OPC and others. So when we have all of these protocols out there and the sophistication of appliances increasing, we can move into an arena where we could have intelligent boxes that receive signals and can, based on a policy that's been set, turn certain things off or change their mode of operation so that we can adjust the consumption of power as close to real time as possible to match with the supply. If we don't do that, we're looking ahead at a lot of peaker units or putting an extensive amount of storage at very high premium prices. And that's not a very good direction to go in large quantities, because the impact on the per unit cost of electricity would be great, and that impact will cause inflation, and its economic impact is quite clear. So I want to give you that backdrop and tell you that those are some of the macroeconomic and the industry trends that motivate initiatives like the one Stefan is working on. So with that, I'd like to welcome Stefan, and he will introduce himself and share a little bit of his background. And he'll tell us about this GNU remote control and how this can help control the thermostat on thousands and thousands of HVAC systems so that we can have that savings at the time we need it. So with that, Stefan, I will now move the ball to your name, and that will allow you to move from one slide to the next. So, Stefan, the ball is in your court.
All right, thank you. Thank you very much. Make sure I've got control here. You see my mouse moving by chance?
No, you will not. We won't see your mouse, but if you move those horizontal arrows at the top, it will allow your slide to move from one to the next.
Okay, very well. Thank you. Well, thank you for your attendance today, everyone. Again, my name is Stephen Dawson. I'm the maintainer and the coordinator of a software project called GNU Remote Control. The presentation today we're going to cover is why we believe software is necessary to successfully build a smart grid, along with a high-level overview of the software project. There are some slides at the end of the presentation you'll have that will email out tomorrow. They'll have hyperlinks in them, and it's reference information for you to look at after the presentation. It'll give you a lot of pertinent material to read about the software project, more the scope of what I'm going to present to you today. Candor, I want to say up front, I don't know everything in life, and I certainly don't know what's necessary to build the smart grid we're searching for. But hopefully today we can get closer to knowing how we can successfully build the smart grid. Let's see if we can move a slide. Okay. A bit of information about myself. I am not an engineer. I am not academically trained. I'm not a licensed engineer. I'm certainly not a certified energy manager. My background is in information technology. I've been doing that officially since 1989. At this point, I manage a lot of technology as a consultant. Historically, I've done a lot of entrepreneurial work in the past 7 or so years, primarily in the consulting field with various IT services to go with it. Our project today, there's a lot of team members that are not only software developers. When this project started up several years ago, it was very clear I was going to have to come at it from 4 different angles at the same time. 4 angles. Angle 1, IT. 2, the energy management. 3, the end user. And 4, whoever's paying the bill. The finance manager, mom and pop, CFO, whoever that person is. The intent is to build software that's cost effective. And doing that successfully involves having input from several different people. The people in this particular project, for example, are in the financial investment industry, they are in the mechanical engineering industry, they are in the telecommunication industry, as well as software developers. So today, after the presentation, I'd like to spend a good bit of time answering your questions. We as a project are at a point where we've got a long list of what we could do, and I personally am searching for qualified use case scenarios to know which way to grow, to know how to prioritize our time. So we're growing the way we should grow to satisfy the users to build the software that they want to use. We are focusing on where our software right now fits into the bigger picture of the smart grid. What we could do is not our priority. What we should do is what we're trying to accomplish. We want to determine, qualify, and understand the demand for the capabilities to this software that we could add that people want to use. And today, the software manages HVAC thermostats to achieve comfort and cost effectiveness. Tomorrow, we're looking to incorporate demand response, and hopefully we're going to get there. So today, here's my agenda. We're going to get right into it. We're going to focus on the problems we're addressing with this software project, the background on those problems, the technical answers we provide to solving those problems, and the financial side I spoke to, the energy management equation that's guiding our efforts. My goal today is to inform you of, again, capability and potential today and tomorrow of what this software project, GNU Remote Control, has for the smart grid. I'm going to speak to both the residential user and the commercial industrial user, and I'll do my best to separate those as I present. A few acronyms: HVAC, heating, ventilation, and air conditioning. IT is information technology. Energy management is EM. It's amazing how many people I work with don't understand those. It really is not a common understanding. In this project, we have a good understanding, but I don't like to assume. Okay. The value proposition has been on my mind for many, many years. I have studied this thermostat device concept, both the physical and device and the virtualization of the thermostat for many years. And I've been fortunate to be able to study it from the engineering, the finance, and the IT perspective. The conclusion I have come to, after many years of looking at this topic, is that HVAC thermostat is not widely being used to achieve efficiency gains, or cost savings, or even effective control of comfort level, because there's a lack of measuring the benefit it could bring to us, along with the absence of how to accomplish structured management of the thermostat. So several years ago, I focused my efforts and said, what is the value proposition? What is the benefit do I or you or we get from adopting a structured approach in managing the HVAC thermostat after we take account of the cost? And I concluded there was a lot of value. So I'm going to go through a value proposition formula to explore the reasoning and examples I came up with, and then apply that to see what this thing could look like in the future. So the problem definition. Most people do not follow a structured approach to the management of this thermostat for three main reasons. Reason one, we often cannot remotely get to the thermostat device. We got to walk up to it, we got to change it by buddy, we got to call somebody. Reason number two, we are not recording usage data of the thermostat. Usage data in the form of runtime, how much heat, how much fan, how much air conditioning. And reason number three, we cannot consciously improve anything if we're not measuring, analyzing, planning, and then acting. We may get it, but we're not consciously doing it if we're not having the data to work off of. So that is the problem definition I came up with. Number-wise, I went out to Bureau of Labor Statistics and grabbed historical energy costs for the past 10 years. Right now, we are at 39.8% price increase for the past 10 years. Again, this came from the Bureau of Labor Statistics. Energy cost is going up every year. Now that may or may not be good if you're producing energy. Higher costs for the consumer does not necessarily translate into direct profits for the energy producer. Now the higher costs may be due to higher production costs. In which case there are no higher profits being captured by the producer. The producer simply passes on the higher cost of production to the consumer. Now, if the energy producer cannot even pass on the higher cost of production to the consumer for any reason, whether it's competition or regulation, then the producers may suffer a loss financially. And here's the same numbers I just presented in the graph. And you can see that's almost a 45-degree line for the past 10 years. Again, Bureau of Labor Statistics. More data. Energy Information Administration. They state an estimate that energy consumption in the United States is roughly 40%, residential and commercial. Now they also provide a lot of data and charting to their number, both monthly and annual. I encourage you to go out after the presentation and look at that. It's fairly intensive for them to do that kind of research, for even thousands of facilities. And I think a few years ago they canceled some of the surveys because of budget cuts. But the concern I want to voice is this is only an approximation of energy consumption. They do not have a direct way to measure HVAC consumption. Now this direct measurement is a benefit provided by this software project because you're talking to your thermostat, you're measuring runtime. Well, let's go with 40% right now because that's what the Energy Information Administration tells us for both residential and commercial. Another piece of information I came up with was a paper that came out about a month and a half ago from the Edison Electric Institute. It's an executive paper. It talks about the financial implications and strategic responses to electric retail business. It's pretty good. I encourage you to read it. It talks about the context and the nature of the industry, but it gave me a lot of tangible about where GNU remote control could fit into the industry of today and the near future. Now, some excerpts from their executive summary. They do present some strategic responses to the competitive threats, the threats being investor capital, what the investors want, and specifically what they want. They highlight several investor expectations and objectives, and they present a business model transformation alternative. Now, the loudest thing I got out of this paper was EEI recommends 30-year investments need to be made on the basis that they be recovered in a timely manner. They define a timely manner of 7 years or less. That is a very aggressive goal. What they're really saying to me, I hear, is things are changing fast. And spend the money wisely and recover your loss, and hopefully you'll move into a profit very soon. 7 years is, when you think about the energy industry, I don't know anything that moves that fast, but hopefully we can get that accomplished by building a smart grid. This slide I saw, 2000, 2001, and it has spoken volumes to me over the years. It is a usage model. I got it out of a magazine. I can't even remember the name of the magazine years ago. But it describes how user engagements determines system usage. Now, case in point, awareness, competency, and willingness. Awareness. Are you aware you're supposed to be punching your time card? Are you competent to punch your time card? Are you willing to punch your time card? Are you aware there's a demand response program? Are you capable to use it, Mr. Homeowner, Mrs. Homeowner? Are you willing to use it? And again, the overlap between these areas determines systems usage. Now, I can build something, but if nobody's willing to use it, I'm wasting my time. I can build something. If nobody can use it because they're not competent, I'm wasting my time. If I have built something and nobody knows anything about it because of a lack of awareness, then of course they're not going to be able to use it. So thinking about this from a demand response perspective really opened my eyes about 3 or 4 years ago, and I really started considering demand response. Pretty picture I came up with. This is what I see when I think of IT and information management. We are part of the picture, but we're not the whole picture. We must work with other parts of the picture to get where we're trying to get to, which is successfully building and managing a smart grid. The upper right is kind of where we're at now as a country, and the lower left is where we're trying to get to, build a smart grid and manage it. So when I say, well, who else is riding this train, Stephen? Well, of course it's end users and energy managers, but I came up with a list of stockholders, financial lenders, government regulations, special interest groups, employees, even foreign countries, depending upon the scope of the organization. So this illustration, it gives me the understanding of control to safely start and stop the entire train, which is, the analogy of the smart grid. Information technology is an enabler to many of these great ideas that have been shared in the different presentations about the smart grid. Therefore, he's been hosting for us. But information technology is not only a delivery mechanism. And many of these great ideas about the smart grid, it is also a value proposition in and of itself. So pardon the pun, there's no need to reinvent the wheel. Let's use the information technology that we have today. It's a well-proven capability. So do we need software? Good question. Of course we do. But I'm going to ask some loaded questions to spark your thoughts. What are your energy costs? Is there a simpler way to manage data? Not just a spreadsheet, not just a quick calculation. I'm talking the management of data, processing and analyzing, volumes of information. And involved with software licensing. What license is appropriate? The cost. So the overarching benefit of this project is cost reduction, not just touching thermostats, not just quick buttons and simple, pretty pictures. The overarching benefit is cost reduction. So a software license, of course, has to be considered with any value proposition. So after many years, I came up with a very simple list. A thermostat capability. The revelation that came to me is the difference between features and the difference between settings. And this is a paramount understanding. And I felt, how can I miss this for years? When it stared me in the face. But this is how the problem definition was built and how the research shaped the software we've built. So my understanding is the HVAC thermostat commonly has 3 distinct features. Feature 1, a way to turn the heating on or off, is a binary action. A way to turn the cooling on or off, again, a binary action. And then a fan to move either the hot or the cool air around. Now, it is definitely nice to be able to set these features up, save some money at different dates and times, but this setup results in increased comfort and sometimes increased energy efficiency, and in turn lowers the bill. But it's not guaranteed. So this was a huge revelation for me. Condensing that down, heating, cooling, and fan are controlled by settings. Again, I can't overemphasize this enough. This is a paramount understanding. Another way to say that, very simply, is features are controlled by settings. So that is the essence of the thermostat, and that is the essence of what we're trying to accomplish with this software project. So putting all that terminology together, let's just play with some terms. Turn a feature heating on until the temperature reaches a setting of 72 degrees, and turn the heating off. Turn the feature cooling on until the humidity reaches 40%, and then turn cooling off. Or turn the fan on at 10 a.m. on Tuesday for 15 minutes, and then turn the fan off. Now, this is when the lights really started clicking for me. Now, this is definitely an IT toy. So then the question becomes, what settings? What's the definition of set correctly? I don't know. That is a relative answer. It is relative to every user in the room. It's relative to whoever's paying the energy bill to balance comfort and cost. it's a question that changes every minute of every day. I probably change my thermostat 20 times a day. The East Tennessee area is a very humid area all year long. So I'm not changing for temperature, I'm changing for humidity, but 20 times is a lot to fool with. If you're running an office, 2 shifts, you got 16-hour, 18-hour days. Certainly several changes to keep the people productive and happy and keep the energy bill satisfied. So the best question I've come up with, or answer, is a question: what matters the most? Is it the combination of comfort, or is it the lowest cost? That's a question I can't answer. That's a question nobody can answer. Only the end user and whoever's paying the bill. Now, the common answer is somewhere between comfort and cost, and software certainly helps, do that rather well. But that is the goal, is to have this balance between comfort and cost. Date and time. One more slide before we get into the next step here. The correct setting of date and time on a thermostat is a very common obstacle to balance. Case in point, daylight savings time. It's coming up this weekend. It's already happened in some countries. But, just go through a few examples. These are very simple. These shouldn't be a surprise to any of us. You set your thermostat to 5 o'clock. Set it to cool when you walk in the door from work. But you forgot to change it for daylight savings time, so you'll walk into a warm room. Or you're working on a large commercial site, and you set up a data logger to capture temperature and humidity for about a month. And daylight savings time happens during that month. You got bad data for certain weeks. Now, you may have some great software doing thousands and thousands of thermostats. But some of those thermostats don't observe daylight savings time. Some do, some don't. Again, the data can go sideways very, very fast. The answers are very, very simple. Simplify the energy management, determine energy costs, build and maintain the smart grid. And this, to me, is two different aspects. Just because we built it, I don't think we can maintain it. And, of course, we can't maintain what we haven't built. So this, I believe, is the goal we're going for. And to get there is going to involve a lot of determination of energy cost. And I think we're going to come up with much simpler energy management. So we're going to see ways to knock all kinds of rough edges off once we start measuring. So do we need software? Yes. Yes and yes. All the nice software in the world, it keeps the settings and the features very, very simple. It is data-driven decision-making, and that is going to pave the way for demand response to optimize cost versus comfort. Technical. We drew this idea up on a piece of paper, literally, and discussed at length what technology best suits each piece of the software framework. We came up with a relational database and a web application to drive that database. We selected MySQL and PHP for many reasons. They're very popular, they're very proven. We've had developers check in and check out to do some work. They're not going to be involved forever, but they've been able to contribute because they understand these technologies. And the larger, the more diverse the development team, the more likely we can build something that provides the capability of managing the smart grid. Perhaps along the way, maybe we'll achieve innovation. We hope so. We don't know. This is action. We're trying to use our skills to help, not just recommend what should be done, but to actually help do it. We see the need for helping with the bigger energy management challenge. Those of us working on this, we personally benefit through lower energy costs and being associated with what achieves lower energy costs. We can help build the smart grid. Everybody wins. There's some eye candy. Let's talk about the way this looks. It's a very simple web application. If you can do Facebook, you can use it. There are 3 pages. An administration page is the first step. You set up your user accounts. You can even read this. It's kind of tight, I know. But the username is the same username you're setting up your web server. Web server handles all the security for you. We do not handle security. On the right-hand side, there's some groups. We've got this ideology that throws thermostats into buckets, into groups. It's a developmental idea we've come up with. And that provides the ability to have different administrative privileges, to handle different thermostats, different groups, different locations. And it also allows the folks who you set the passwords up for of the thermostat to be separated from the users, to be separated from the administrators. It's separation of duties. The people that admin this application do not have to be the end users. The end users can be the day-to-day in your call center of a public utility, a building supervisor versus the IT department versus an energy manager you may bring in once or twice a year to look at your facility. Next page is where you set the daily activity up. Left to right, it's a huge table, and I've got this spread across 3 slides so you can read it. First thing we do is we enter the information about a thermostat. What's the network address, what's the password of the thermostat. And then you put it into a group. In this example, I came up with first floor, second floor, third floor of a big building, both in Knoxville and in San Francisco. Come up with a custom name, a description, very simple ways to identify these things. And then we read the device. We go out and grab the device name, which is separate from the custom name, the site name. Plenty of fields to play with, plenty of fields to manage all of your activity. The next slide you simply check what thermostat you want to talk to. In this example, I'm grabbing all the north and south, and I'm setting the heat to 70 degrees. That's all I'm doing in this activity. On the right, there are sensors if you had multiple sensors set up for the thermostat to measure temperature and humidity, but I won't deal with that now. And at the bottom of this same web page, there is scheduling. There are 4 setback periods, is what it's called. Well, that's great if you've got 4 periods in your life. If you have 20 like I do, I need more. But again, if you've got a standalone device, this is not bad. It's just simply a limitation. There's a big button called Submit. So I would go out and set all the heat, 70 degrees, the thermostats I've identified, and we go back of north and south on the first and second and third floor. Pretty simple. Shouldn't be too complicated. Next thing I do is I have been told that people want the thermostat to be set on the east side of the building at 72 degrees. So I select all those 3, set the heat to 72 degrees. The next thing I do, I've been told to set the thermostat on the west side of the building to 71. Okay, glad to do it. This is the day in, day out activity of using the user interface GNU remote control. The third and last web page is the transaction history, where we log all the activity that we've done, succeed or fail. Here you can see I went out beforehand and I set the time on all the thermostats, just to make sure if somebody's using scheduling, the date's right, the time's right. Everything you've seen lives in a relational database. So you can use database management to read, to plan, to see who's changed what, when they changed what, and actually make data-driven decisions. Now, you can combine this certainly with what's the outside doing? What's the temperature outside? What's the humidity outside? Plan for demand response. If I know these people historically like to run the thing at 72 degrees, and I can see from the run time on the thermostat, it takes about 10 minutes to get there, I can pretty close guess what it's going to cost to run an electric on that particular side of the building. Translate that across the whole building, translate that across every thermostat you're in charge of. Numbers start falling in place. And again, separation of duties helps because people are assigned the task that's best suited for them. Are they an IT person? Are they an energy manager? Are they the end user in a call center or a building facility administrator? Are they the finance manager? They want, give me some numbers to work on here to plan for next year. So hopefully we've accomplished satisfying as many user roles as possible, because we've tried to approach this in these 4 different perspectives. And again, this is a screenshot. I just gave you the transaction history so you can look at it later for some understanding. Today we're at version 1.1. We released that at the end of September. We need a thermostat to build against, so Prolific's had pretty decent product. It's IP and Ethernet enabled, and it also has an application programming interface. So that allowed us to build an IP Ethernet enabled thermostat management application. It wasn't a good or bad decision, it's just we picked a thermostat. And it resolved the problem definition we had. It gave us the ability to manage the data, to remotely read the device, and then plan for using the device. It worked out pretty well. But people say, what about other thermostats? Well, not with us. All we got to know is 3 answers. How do we connect to the thermostat? What network? Is it Zigbee? Is it Wi-Fi? Is it Bluetooth? How do we connect to it? How do we read from it? And how do we write to it? You see today there's going to be dozens and dozens of thermostats out there in the marketplace. But I doubt it's going to happen until there's a way to manage thermostats. And this is most likely going to accelerate more thermostats coming to the marketplace. That could be the innovation that we've been thinking of. Innovating the marketplace with more competition, with more products, more features, driving the price down. Same thing like a cell phone or a car. I mean, it would drive the price down. How it couldn't? But I don't know. Anyway, these are the 3 answers we need to know. So let's go talk about the value proposition. We came up with the funny word, just smartness. I mean, this is what we're contributing to the picture. It's a funny way to say it, but an electrical grid that involves smart is going to have to be able to capture data, analyze data, and do something constructive with that data. So we go back to the problem definition. How do we achieve that? What is the background? What is the solution that we can see? What are the technical ways to build it? And the capability we believe we're providing is, it helps get the smart grid into the hands of end users so they can have more comfort in their buildings and do so in a cost-effective manner. Adoption is what we're, probably the easiest way to say it. But finally, we're adding a benefit to the smart grid. We are connecting many technologies. We are empowering energy producers and consumers to predict energy consumption. And loads of other capabilities we can talk about here in the presentation, but data-driven decision-making is a point. So the reasoning for the belief I've come up with on this value proposition is we're doing the data management to remotely manage settings and features. And it doesn't help to only read. We must be able to write to the device as well, to change those settings. And those capabilities are going to lower the energy cost and predict demand. Analysis, that is a future capability I'm going to talk a little bit more about. But that's where we're going. Once we've got the data, we can actually analyze and do something with it. Examples, single building, multiple buildings. If you've got a bank with ATM machines, if you're a couple of fast food restaurants, if you're a multi-story building, the location is not a barrier. You don't have to be in town. You don't have to roll a truck. You don't have to pick somebody up in America to go look at your unit. Because this is a flat topology, because as much as the internet and as much as the network, you can get to it, you can manage it, shy of a device failure. If you have to reset that device, if you have to restart that device, that's not that bad to accomplish anymore. So what we're doing is we are improving existing implementation efficiency. Well, you think you need more of a fan. You think you need more air conditioner. You think you need more heater. How do you know? Are you using what you've got the best you can? I don't know. That's probably what the boss is going to ask. It's probably what the finance man's going to ask. How do you know you need to spend money? Existing implementation efficiency is going to have to be, you know, you have to go through it. So I think the analysis of the data is where this is going to get really fun, because we're going to find patterns not only regionally but nationally. I think they're going to surprise us. I think we're going to realize there are trends out there that we've thought about for years, but we can now act on because we're doing data-driven decisions. So looking future-wise, potential. We can use that data for demand response. We can adjust loads, theoretically, once we figure out how to connect the two, and improve the efficiency of existing implementations. Now, probably the best case scenario I can think of is demand response, straight out of the textbook, is when the consumer equipment senses conditions of peak demand and regulates downward automatically, which is what Efrain was focusing on at the beginning of the presentation. Now, this is the direction we're trying to get to, but I want to make sure that the demand is now through qualified use case scenarios before we go build something that somebody really can't use. The simplest way for us to get there is going to be, well, let me hold off on that. I don't think that's the time to bring it up. Getting this built, that can be literally accomplished by reading the thermostats, measuring consumption, and comparing the outdoor weathers to estimate the future consumption. Now, the biggest hole in the statement that I just made is knowing how much energy a specific implementation consumes per hour. Is it 1 ton? Is it a 2 ton? Is it a 5-year-old unit? Those are big questions. But if I can look historically at runtime and say, they're taking 15 minutes to cool this thing off 10 degrees day after day after day, then I can estimate the efficiency of the unit and, estimate future demand. The license, I looked at this license for several years. I spent about 13 months deciding what license we should release this under, and I selected the FARO GPL, General Public License, under GNU. I'm very happy with it. There's no license cost. There's no regularly recurring license cost as there is in proprietary. There's the source code to edit the source code if you want to. The biggest value is collaboration without the additional license restriction. Someone introduces me to information, and I can structure that information. So when the next person comes along, they don't have to spend 20 years getting up and running. They can look at the application. They can look at the manual. They can understand what it's going to take to build the next piece of energy management faster as a team, particularly with collaboration on a global basis. I mean, we've got a footprint in Europe. We have a footprint in America, and we've got some footprint, not much, but in South America. So we've got cultural and language things happening communication-wise like I can't even describe. Just to get the same message across to the same people. It's fun, but on the same token, it's enabling me to see, just because I care about humidity reduction in my home doesn't mean anybody else does. They've got different challenges. They've got different costs. They've got different regulations they're living under. It's really helped me, I think, advance this project because of this license. A few more slides and we're done here. Home page, this is where we're at on the GNU site. The documentation, it's built 3-part: user manual, technical manual, and reference manual. This hopefully is one-stop shopping for people to get what they need. It's broken into 4 groups: end user, information technology, energy manager, and finance manager. So they can get what they need very fast out of this manual. It's about 40-some pages. Print it out. The blog I use every month speaks pretty direct to what's going on out there in the retail energy world and how that impacts both producers and consumers. Plus, it gives me a way to talk outside of version releases that could be a few months, who knows, a few weeks apart. So where we're headed, I think, is demand response. That's the hot one. Unattended server-side automation. That example I went through about changing temperature and, San Francisco and Knoxville and the east and west, every bit of that can be automated. That depends upon how you identify what servers or what thermostats you want changed and when you want them changed. I think we should handle it in the database, but I don't know that. I would want to get more use case scenarios before we go build anything. And then this group functionality. Instead of selecting individual thermostats, just check everybody on the first floor, check everybody on the third floor. A whole lot easier way to use the user interface. Some other things we've got on the to-do list, the wish list, the think list is power line communication. Do we need to build a thermostat emulator? Do we want to emulate 1 million thermostats at the same time? We couldn't do that physically. We can't have a football field. Do we want to build an asset management system for commercial industrial facilities that have 50 fans, that have 100 fans, plus 55 different heat sources? Do we want to build a tablet version so a person can walk around and make some easy changes when they're walking through the facility? There's some requirements in the United Kingdom and Australia for accessibility. The information is presented on the web page. I recommend you download a copy, set it up. It wouldn't take you too long for an IT person to go through and set up the web and set up the database. You can get a feel for it on your own. If anything, read the manual. I've got that broken into sections, so it's pretty simple, I think, to find what you're looking for. And my bumper sticker pitch is I believe software will help get us there. I cannot see how we can build a smart grid without software. I cannot see a smart grid without HVAC Thermostat Management on a daily basis. If we can get this into the smart grid, which I believe we can, but if we can get there, then that 40% energy that EIA is saying is consumed both at the residential and the commercial level, we will have dramatically got a handle on energy in this country. Plus, we'll know exactly how much they're consuming because we're measuring runtime. I think that's going to be a very big eye-opener. I don't know what it is, but I bet you it's about 25%. That's my rough guess. I bet you 25% of the energy in this country is HVAC related. I don't have a lot of data to back that up, but that's my assumption. That's a huge, huge, huge pile of energy and money. So to recap, I've gone through the problems on slide 9 that we're addressing. I've gone through on slide 24 how we're addressing the solution. On 26, the components of the solution. On slide 37, the benefits. And lastly, let's talk questions. I would love to get your feedback on where you're at today, what your thoughts are, so we can start categorizing the use case scenarios I've come up with and decide what we need to build next. We're all trying to get to the next smart grid, so I don't want to make assumptions. I want to get there faster than slower. So that is my presentation.
Thank you very much, Stephen. And as people start posting their questions online, let me start by asking a few questions. It seems from your presentation that you're looking at HVAC as an area that could potentially provide some savings in overall energy consumption. You showed statistics of 40% of overall energy use being used in residential and commercial, and then HVAC is a significant fraction of that. So are you proposing the work products of this initiative as a way of helping with energy efficiency or demand response? Which of the two are you more focused on?
I don't see how we can separate the two. In order to have improved efficiency, there has to be an incentive. I think the incentive's been absent from the marketplace. I'll give you an example. I was doing some research last night. Duke Energy has a residential HVAC demand response program. And if you use that, you get $25 a year off your electric bill per year. Dominion Power in North Carolina has a similar program for $45 a year. I don't know if $25 or $45 is enough to incentivize people to use it. The way I see change has to be incentivized. I think one of the reasons we don't have change occurring is there's not enough incentive to get there. I can save on my bill. Okay, that's me. Demand response is about the larger power supply, the macroeconomics we spoke about. So in July, when we don't have electricity and we go through roaming brownouts, then I really care, but that doesn't matter. So in order for me to have energy efficiency, I believe I'm going to have to be participative in demand response. Demand response is going to help keep, well, likely to help keep my electric bill down, my electric supply available to use. And in the end, it's probably going to increase my comfort as well because I can have more accessibility to run my facility. Residential versus commercial. Commercial is the big one. That's probably the toughest one to manage. You look at a lot of offices today, and they're very densely populated. In these hotel cubicles, they'll set up tables, and you've got a population in a building that's much more than what it was designed to handle. So you're going to have a whole lot more carbon dioxide, you're going to have a lot of moisture. People literally are going to have more humidity in the building. So the people that are running the building are trying to fix these problems, and without the ability to measure it, they're not going to be able to really understand how to fix their problems. So they say, well, the electric bill is going higher. Now we're paying more because we've crossed so many hundreds of thousands of kilowatts per year. Well, we got to do something about it. What are we going to do about it? Can we get into demand response to save the money? How do we get into demand response? Well, we got to be more energy efficient. So I have to believe that energy efficiency and demand response are going hand in hand, because the incentive is to be for people to participate, and it's certainly going to, I think, it'd be more than $25 a year. I mean, I don't think a lot of people really matter for $25 a year. Why would I want somebody to change my thermostat for $2 a month? Is it really enough to get people to participate? Probably not. But that's just my analysis of the problem. I don't think we can separate energy efficiency from demand response. Which is why I'm considering adding that capability to the software project.
Okay, just as a follow-up, Stephen, the point I was trying to make is that the way demand response is being offered in the industry, it's to shape the particular load to meet a certain shape. And that means sending a signal at certain times for certain things to either come off or change their mode. Now, that has, in the short run, an energy savings aspect because it's clipping peaks. But what it's not doing is it's not telling the customer proactively how should you operate your system so that you have the most energy efficient outcome. For that, you have to take the data that you're collecting and then give them actionable intelligence so that they can set their thermostats proactively in that way to be energy efficient. So while I agree with you that the terms are connected, but one does not necessarily directly lead to the other, is what my point was.
Oh, I absolutely agree. I mean, if there's poor insulation in the building, if there's an energy efficiency problem from the lighting or the windows have crack in them, you're never going to be able to defeat the energy consumption of HVAC. Those are contributors to the problem. So I agree with you. They are not one directly related to the other. It's a cause and effect. Maybe that's the best way to say it. So
I think that the demand response infrastructure can allow you to collect the data on which you can do the big data management analysis, the business intelligence, and then develop energy efficiency programs to help the customer reduce their carbon footprint, in other words, lower their energy consumption.
I agree with that. I do.
Okay, very good. So we are getting some more questions here, so I'll go to those. One is from Paul Heitman, who asks, is the assumption that the underlying energy is electric? HVAC uses significant amount of natural gas in some regions. How about water? Worth it as an application?
I'm sorry, that last part about what about the application?
Well, he's talking about that the underlying energy for the is electric. So he's talking about the HVAC system as in an electric system, or how about water and other things that could be used with this kind of application?
Okay, I didn't get the last part. This call broke up. Okay. Yes, Paul, I agree. The reason I chose electricity for the presentation is because that was a national metric provided by Bureau of Labor Statistics and the EIA. Some people use a lot of heat. Some people don't. I was trying to approach it from a national. Yes, I think natural gas is a big player. Coal is a dramatic change of coal, but we're not focusing on how energy is produced. I'm focusing on how energy is consumed. If there is, case in point with this particular thermostat, there's the ability to hook up external sensors. There's just a feature they came up with. But I think this is going to answer your question better. Even a float switch, on a system is going to involve water passing. So when the switch closes, then it goes to the thermostat, so that sends the alarm, and then there's awareness there's a problem. I think that's more manufacturer-driven about how they want to actually build a circuit board with connections. But yes, there's no doubt. I mean, natural gas, even propane, water, steam, it's huge in the United Kingdom, steam heat. But conversely, I was in the South Pacific a few years ago, and there was just air conditioners. There's no heat source in the South Pacific. And mostly in London, England, there's no air conditioning. They just open the window and they have heat. So the reason I chose electricity was to have a national number that I could present. But I agree with you, water, natural gas, propane are part of the measurement. And yes, those are going to have to be addressed. Now, natural gas provides a ping, which is different than demand response. I don't know. I mean, there's HART technology. We can interface with it, yes. I would love to include those technologies, but it's a matter of if we can interface with it from the public utility, what can they provide us for communication?
Okay, let's continue. The next question from Paul was, is there a goal to have utilities adopt when they deploy the thermostats under a rate-based DR program? And would EPRI be a good authority to drive standard implementation?
I mean, are you asking my opinion, or are you asking if there's a hard
Yeah,
no,
yeah, he's asking based on your best assessment of what's going on.
I think the fastest way to simplify this topic, HVAC management, is to have an international standard, or if you want to just say American, let's just say American for our discussion today. This is a thermostat. This is how you communicate with the thermostat. We've done that through IP. We've done that through Ethernet. The entire World Wide Web is built on those protocols. And it accelerated growth and adoption. I would think today a manufacturer that's trying to build a thermostat has a great challenge before them because they're trying to decide what communication protocol do they want to use. Wi-Fi, wired, Bluetooth, Zigbee. Once it's sold and once it's shipped, there's no way to retrofit that circuit board. So if I was to have a best case scenario, I'd say come up with a definition of the thermostat so people can start building thermostats, getting them to market. We'll adopt the software to match that protocol. And by definition, all the thermostats, all the software, they're going to work together. It's like a cell phone. Do you want an LG? Do you want a Samsung? Do you want an Apple? If it works, it works. So then that way we've got competition, increasing features, and driving down prices. The marketplace takes over. But I think there's going to have to be a common standard before people are going to build and ship those devices. And the proof is IP addressing and Internet. I mean, it radically built the Internet very fast.
Yeah, and also, these types of interactions, especially if they're happening frequently, will have some bandwidth requirements. And also, you don't want to put the burden on the smart meter for this type of application, because if that becomes the gateway and the application becomes more and more byte intensive, then the meter will become the bottleneck, and both in terms of the pipe, the size of the pipe, as well as the memory and processing capability. And with such a high concentration now of broadband internet in our country, it seems it makes sense to divide the problem up and just focus on meter reading and remote connect, disconnect, and watch the network with the smart meter. And then this type of application that you're talking about could come over the internet through a router to some kind of a coordinator that could then talk to the PCT and other things on various technologies.
Yeah, that is a nice way to do it. But another way to get there is power line communication. Now that would cause the public utility to probably change the technology they've got out of the pole on the street. But that would solve many problems. That would have the device powered and communicated. It would also take the device off the internet, increasing security because it's not directly facing the internet. Now,
I think that particular power line technology could be very effective in the house using a home plug type thing, because many times, the PCT may be located at such a place where the wireless communication may be difficult, or there may be interference sources or other things. So it makes sense to use that 24-volt AC line to send the signal, and you can get, you can kill two birds with one stone that way. But those are architectural issues. I think it'd be good if we stay focused on the business aspect and who do you see as your customer? This is one of the questions that was asked earlier. It says, who is the customer for this output of this project?
I think the best case scenario is a public utility. Now, let me explain why. Public utility already has a well-structured interface with the residential user. They've got the government regulations, they have the call center, they've got the field personnel. Penetrating the residential user involves pretty much two wires, one for communication and one to control the device, and with the power device. Let's just say the power device. So if there's a problem with the residential, who's getting the phone call? The electric company or the telecommunication? It falls apart. The business model falls apart. I am sure that the government regulations involved with addressing residential are considerable. And I would think the public utility has a very good handle on that. So the best case scenario that I would see is that a public utility decides to go to demand response, selects a thermostat, field tries it, say 10,000 people. Whether they charge them a monthly fee or not, that's a business decision. Whether they install it themselves or end user, that's a business decision. And they go with it for 6 months. Measure progress, measure performance, measure cost, the value proposition. And if that proves satisfactory, then elevate the project or cancel the project. One of the two.
Very good. Let's move on to the next question with William Miller, who asks, how about local generation and renewables? Trying to influence efficiency through demand response today is difficult. There is no peer-to-peer management of local use between houses, buildings, etc. This can be done using energy sharing between users.
Sounds good to me. I'm not qualified on peer-to-peer sharing of energy, but
all right, let's move on. Will English asks, has this product been used by anyone yet? Would you say your competitors are, and who would you say your competitors are, and how is your product better than what areas can you improve?
Well, we don't have competitors. This is an open source project. It's, use it if you want. The market, the world is our competition, whether you use it or you don't. The implementation right now we've gone through, we launched in January under the GNU license. And the implementation we're going through right now is people are doing their evaluation. They're trying to decide how they want to do a field trial, if they should do a field trial, how they do it. And I think they're going to do it on a scale of 35 5,500, 10,000, some type of structured planning. The improvements that I believe we're at now is I believe it's time to engage more energy managers. I want to further refine how I can estimate residential energy consumption. The things we've got working are, okay, I'm consuming 10 kilowatts per hour. I run it for 10 hours. Pretty simple calculation. I want to refine how I can estimate how much energy each home is going to use, and then plan that out and decide how we need to apply that to the power grid. Is it a mass change? Is it a handful of changes at the time? I can't even imagine sending out millions of thermostats at the same time to turn off because of that hurricane they had in New Jersey, Sandy. If they would have been able to turn off some of that equipment, I think would have survived the power grid a little bit easier versus shorting it out when the water came in. On the other side of the storm, if they could have gone in through the wire and turned on some of those fans, they probably could drive those buildings out pretty faster. So things like that are going to provide, if I can get to the thermostat, then I don't get, well, the power grid in that area is working. I don't have to roll a truck. I can see, because I can get to that house, I've got power in that house. So that's the kind of benefit I'm trying to bring. Okay, to get there, I need to interface with energy managers. I need to interface with the public utility. I need to interface with those third parties to understand how we can grow a project to encompass and arrive at demand response, and then how we're going to manage it. I think if we can design it better, we're going to have a much better success in maintaining and managing anything. Because you can really only control quality in design. And that's a different argument.
I think the point here, Stephen, is to make is that open source initiatives are meant for capturing the mass market, that people with creative ideas can connect with this and really take this into a large scale. And while there are many other efforts going on for controlling HVACs that are not open source, they are for pay and they're funded projects that utilities and federal and state agencies are involved in, I don't think we need to see this in a competitive way. I think we need to see this in a way that solves a particular problem. There may be multiple ways to solve the problem, and I think that eventually this will lead to some standards, because after all, standards are nothing but a best practice, and you don't have a best practice till you have a practice, and you don't have a practice unless you've developed something that works. So there's a process here, I see. And I think there will be a little bit of flux for a while in this business. But I think I applaud your effort to keeping this in open source, because I think that is the way to capture the intrigue of the public and get many, many people involved in this. What I want to understand is, how would this the signals, the commands that you're developing for remote HVAC control fit into the OpenADR initiative that's going on? Lawrence Berkeley Lab moved forward quickly with that, and many utilities are looking at that as the DR protocol. Can you work with that?
Yes. Well, I can tell you the mock-up I've got. I'll give you the 2-minute commercial.
Mm-hmm.
What I've worked at, I've gone through the standard 2.0, looked at the XML, and I've identified what tags we need to use as this project. So we receive a signal, drop the juice for 20 minutes. Okay. So then we take that XML and within the GNU remote control application, use the unattended server-side automation I was talking about, which is the goal of this project. All right, we're going to take all the thermostats 1 degree down to achieve the request of demand response. And we log that we've achieved that, and we send them back their XML tag. We've done it. We accept that. There's really about 2 tags we need to transmit and receive back and forth with OpenADR. So at the end of the month, when we get the electric bill, we take those messages, those events, and say, did we do it? So they have it in the bill, and yes, the bill matches up, so we achieve expense management in procuring electricity or energy. I should say energy because the gentleman wanted to talk about natural gas. And then we say, tomorrow, we're going to need energy. You know, if you go out to weather.com, you get a 36-hour window in 15-minute increments. So that's as far ahead as we can, you know, estimate tomorrow. Tomorrow it's going to be 100 degrees. And we know based upon the runtime of the past how much energy we need. So I can send that message maximum 36 hours to the demand response public utility. This is the energy I'm going to need. So they can plan for that. And if they want to come back and negotiate that, well, then we can negotiate it. But on the same token, we're planning what we need from data-driven decision-making, communicating that out. I think there's about 2 tags we need to mess with, but not too hard, not too tough. That's what I've got working on my end. It's a mock-up. It's not very pretty, but that's the long and short.
Okay, very good. We have a few more questions, and since we are in the last 20 minutes, I want to make sure I get to all of them. Ron Bilodo is saying, if you're using the smart grid to provide communications and analysis, how do you ensure security when accessing the meter?
Well, the meter is something we don't talk to. We're only talking to the thermostat. The device that directly faces the internet is the highest risk. Let me say that again. The device that faces the internet is the highest risk because it can be penetrated. I mean, if you look at the industry, I shouldn't speak to SCADA, but you know, SCADA is suffering because they've got a lot of devices that are not capable of using anything besides password protection. You look at the zero-day virus that's plaguing Java right now, that's going round and round. And if you use Java, I'm not saying it's good or bad, but you are susceptible to the zero-day virus by definition. So one of the values of power line communication is you're not directly facing the internet. And how we get from the GNU remote control server to the device, well, we go across whatever network the customer has, the end user has. In the case of the public utility, it would be IP all the way out to the street, which turns into power line communication and comes down from the street into my house and goes up the wire into the thermostat as a proprietary waveform, reads, writes, goes back all the way to the central office, which is where the GNU remote control server could or probably should exist, or into a data center, however they aggregate that information. The value of software is you're not bound by hardware security. Case in point, wireless. You've got WEP, you've got WPA, you've got different forms of wireless security. And tomorrow there's going to be another form. So if your laptop doesn't have that, or your thermostat doesn't have that, or your router doesn't have it, you're going to buy new hardware. That's a challenge. You've got to replace equipment every so often. And we can handle that. You know, look at security. Well, I'll stop. I can go on forever about security. But any device that publicly faces the internet is a threat. As soon as it's compromised, your infrastructure is compromised. I 100% agree with you.
Yeah. I think that the important thing is to focus on the business application and let the individual utilities with their security folks sit and do a risk assessment of various options and with use cases to figure out what the risk profile is, and then make arrangements for the appropriate architecture. I think one of the mistakes people make in our industry is they quickly want to solve all the layers of the problem right away. Right. And I think that's a mistake because one shoe does not fit all. It depends on the penetration of broadband in your region. It depends on what kind of transformers you're using in your electric infrastructure. Can it handle broadband over power line, or does it have to be a narrow band? All of those things are very, very specific to the vendor products that are in between the utility and the customers. And I don't think we should make universal prescriptions there.
I agree, and that is the value of a protocol. If we can get a protocol spec and written, then we can avoid so many of those problems and increase adoption at a faster rate. Because people are not doing one thing with this vendor and another thing with that vendor. There's interoperability.
Yes. But I do like the modular approach of having a home area network that is private and having the public be different from private and having filters all along the way that ask, why are you talking to me and who are you, and I don't like what you're saying to me, so I'm not going to listen to you. You know, that type of logic needs to be there at certain points between source and destination.
I agree.
Moving along, Ron also asked, do you think customers would be interested in other services besides demand response, such as HVAC status monitoring? Who would own the information transmitted across the smart grid? And talking about the privacy issues.
Well, that's a very good question. Privacy, to me, if it's on the wire, it's not private by definition. The value of also doing demand response is on the comfort side. You know, knowing I've got a facility, I got 350 people I need to get ready for in this auditorium to do a 1 o'clock seminar, planning that. The privacy, well, if it's going across the grid, I think the public utility is going to be in the best position to handle that. They have got OSHA covered with the electricity, the actual, the wire itself, the government regulations. They've got the customer service, so they can handle, the customer facing. The legality, I'm sure, is going to be part of the subscriber agreement between the energy provider and the energy customer. And that's one of the values. Let me go back to the ACRO license. If we can build the software the way a customer needs it, in this case, I'm going to use the word the public utility is a customer, then they don't have to come up with another software license for their customer. They use the software and they use the license that we are using. And it's going to greatly simplify what their I guess burden is, their legal burden. If they're using, what is an example?
All right.
I've drawn a blank. I'm sorry. If the utility provider is trying to service the customer, they're going to find a way to deliver that as long as there's value that they can deliver for profit. But the security that you're driving at, I don't know. I mean, once it's on the wire, well, it's out there. So.
Let me continue. Brad Duggan makes an interesting point. He says, aren't some of the first trends differences in usage that you will identify in the database be different structures? Example, brick, inches of insulation, interior-exterior spaces, ambient heating sources, office equipment, heat discharge, occupant density, and many other factors. So won't getting this database at best just tell us highest usage locations for further study and specific solutions that might address these building design differences rather than the optimized thermostat automation approach? Could this initial effort be better accomplished via energy audits of a sample of different building types in different geographical areas?
No, I disagree with that. And the reason why is because the role of measuring the building is totally encapsulated by the energy manager. The energy manager tells me we need 50 temperature sensors, we need 65 humidity sensors. I say, okay, glad to do it. I put them in, I get them going, I log them. The energy manager comes in and reviews that data, says, you know what, we got to move these 30. So we move them. We get whatever measurement we want. And we've proven consumption. Well, tomorrow it's a different story. We got 100 people coming in tomorrow for that, that auditorium I was talking about, so all the readings are going to change. The best we can get is historical. You're talking about planning for the future. An energy audit is only as good as today. It's only as good as tomorrow, whether it's cold outside or hot outside. I think run time from the thermostat or run time from the unit, let's just say the HVAC, is going to tell me within a very rough order of magnitude how long it takes to cool or heat a facility. I compare that information to the outside weather, what's the temperature, what's the humidity outside, I can get a pretty good, I don't know, maybe 80, 85%, pretty good answer what it's going to take to do it tomorrow. I got a 36-hour window tomorrow. Well, there's a blizzard coming next week. Okay, but the best I can plan for is 36 hours, because that's all I can get from the weather service, 15-minute increments. So if we can get the data captured, and again, the energy manager tells me where to put it. I don't tell anybody where to put it. I capture it. What calculations do you want, Mr. Energy Manager? Okay, you got it. Crunch the numbers. What do we need to do? Do we need to change the insulation? Do we need more fans? Do we need more energy? Do we need more cooling? To get to that answer, they're going to have to collect the data. Now, if you want to go do a building audit, sure, well, we need to change the lights. We need to change. That's a different answer. That's a different discussion altogether. To get there, we have to collect the data. Then we have to analyze the data. Now, as far as composition of the building, the fenestrations, the walls, the illumination, the lanterns, totally different discussion. But they do impact temperature and they do impact moisture. Give me the data and I can crunch it for you. But without the data, I can't do much. So it really is a data-driven decision. Hello?
Very good. So at this point, I think we've covered most of these questions here.
Okay.
So I would like to, do you have any final comments, Stephen?
Comments? Well, again, my request. I think we need to capture use case scenarios for me to know how to grow this project. I don't think I can realistically ask anyone to do anything, whether I'm paying them or I'm not paying them, until I've got more information. And I believe demand response and unattended server-side automation after demand response is where we should grow this project. So for me to get these use case scenarios, I would love to hear real-time problems. I would love to hear pain points people are having, whether they email them to me or they type them up, whether you want to talk, however you want to deliver that information. If I can get a better understanding of the problems people are facing today with their energy consumption, whether it's residential or commercial, then I can better qualify how to go speak with the public utilities to talk about demand response. To go say, energy manager, I need this calculation to know if I'm really measuring residential energy. Commercial is a whole different argument, and industrial is even a bigger argument. I think the thrust is going to be residential. And I don't want to spend the time with an energy manager, and I don't want to spend the time with a public utility until I'm ready to have those discussions and really bring them hard questions that I like to get answered. So if I can get these use case scenarios worked through, then I can understand how I can take the ideas we've got in rough form and really start building out the capability that I'm thinking in my head is going to be demand response. And once we've got that, then we can get into unattended server-side automation. That's really going to be the gold. You've got thermostats in groups. You've got thermostats in building. You're trying to drop energy. You're trying to optimize efficiency. What thermostat do you want to talk to and when do you want to do it? That's all we got to know. You want heat, you want cool. That's okay. You got it. But, getting there is talking through the scenarios. And that's what we're trying to capture right now. Hey, can't build anything without research. I mean, it's all, research at this point.
Well, I appreciate the effort and appreciate the initiative that you are participating in. And we see the implications of this on a large scale because HVAC is such a big percentage of our energy use. And having open standards-based things, especially if they can be provided in an open source environment, enables mass adoption. And we've seen that in many other sectors of our economy. So thank you for the presentation and thank you for making us aware. Now we have to work on the two other circles of competency and willingness. But I think you've done a big service in terms of improving our awareness of this. Coming back, so thank you, Stephen, for that presentation. I wanted to just remind everyone about this December 12th event, and there is a formal application process to participate in this event. from the White House. That is, NIST is also collaborating with that. Jeff Mulligan, who is a Presidential Innovation Fellow and is working currently at NIST, asked me to share this with all of you. So the information is all on this PDF document. I'm going to be sending this along with the presentation and the webcast recording later. The next webinar is going to be in the second week of November. I will be sending you an invite of that in the next few days as the speaker gets finalized. And also just wanted to give you a heads up. Yesterday we had the open house for the GridStar project, and there were over 300 people who showed up at the Philadelphia Navy Yard. 2 weeks ago we had a presentation from Professor Dave Riley about this project. It is a workforce development project, and now it's moving from the public sector to the private sector. And I've been retained by Penn State through Siter Corporation to be its Strategic Innovations Director. And I will be looking forward to all of you looking into the GridStar program and see how you can contribute into it in the 4 areas that I've defined. One of them is education. The second one is collaborative research. The third area is specialized projects. And the fourth area is certification. And we have a microgrid connected to an unregulated distribution feeder line going to a substation. We have solar panels on the home. We have 150 kilowatt hour storage with inverter, and we're providing frequency regulation to PJM. And also we have EV charging outside the house. So we have all the elemental blocks of a microgrid, and we would like to do research on various protocols, cybersecurity controls, and the information models that we're using in the last mile. How will all these various protocols work together, like DNP and Smart Energy Profile and IEEE 1547 and SIM and on and on and on. There's so many protocols that we are looking a la carte. It would be very nice to have a facility where we can test the interplay between them. And we're offering GridStar as such a place, and it would be really good, and this is why I'm asking all of you to participate in this for the public good. It helps the utilities in North America do their job better. It helps the vendors in terms of opening up a clear roadmap for their product innovation, and it helps the subject matter experts prove out a lot of their intuition. So I will be telling you periodically about this initiative, but yesterday's open house was a huge success, and Penn State and BOE and all the supporters from the various vendor companies who provided cost share were extremely delighted at the response from the industry. So with that, I'll bring this call to a close. I will end the recording. Everyone enjoy the Halloween weekend. Also, don't eat too many sweets, and we will see you in 2 weeks. And a good afternoon to all of you. Bye-bye.
Thank you.